not so many days back then, but since we minted it. And yeah, the link to the collection is, I put it in the chat so you can go and check them out. Maybe you know someone who can be willing to align with our agenda, with our cause, and perhaps support it. Because the sole reason we have these NFTs deployed is simply to find support, to continue building, to continue um, researching, to become better developers in general. But you all know that for something like that to happen, there needs to be a lot of resources in place. And this is one of the ways we are trying to master the resources that we need to achieve our goal as Web3 developers. We could revolutionize a lot of things with just the convenience of being able to build, being able to research, being able to um, generally become more conversant with Web3 technology. And yeah, would appreciate your support in every way you can, whether you continue sharing information about this collection, share it with people that you believe can understand the cause that we're trying to put across to the Web3 ecosystem. And yeah, would appreciate every kind of help you can offer us. Even a purchase would be much better, actually. So yeah, this is the collection. You can look at each of the images, see which one aligns with you most. Yeah, there's a number of them. Yeah, and they're actually up to 10. So they all look like images of nature, but they are symbolic in line with Web3 if you look at the descriptions of each of these images. So we had to find something that is catchy, something that is relatable, because code directly may not relate. People may not directly relate with code unless they're actually deep developers. But the purpose of this collection is easy to understand. It's relatable, and we had to find a collection that has images that represent our cause. And yeah, that's why we focused on images of nature. And our interpretation of all these images is in line with Web3 and this journey that we embarked on of becoming Web3 developers. So I think with that, it gives a clear description of what this whole collection is about. So you can check it out. I put the link in the chat. And yeah, I hope to see it blowing Twitter up. Thank you very much.
Oh, mm, mm. Kaspeed. Kaspeed, yeah, I love the energy. I love go-getter spirit. Chasing the money. Yeah, surely there's a lot that needs to be built, and yeah, such I think funding is the best way to demonstrate our capabilities in the Web3 space. And I hope you guys get great places to showcase X. X, I don't know, man. Manjo was talking about, I don't know, just having an X handle for them. I don't know. For me, I'm just excited. Whatever you see around it, I'll have to share. You guys, we need to, I think we can start. Yes, Tracy? Oh, I don't know who has put up the hand. Whose hand was up? Somebody's hand was up.
Hello,
Hello.
am I audible now? Okay. So I was wondering, I checked, like the pricing on these these NFTs and the collection. They are pretty pricey for average people like me. But there is this platform called Fakasta. There are people there. I think they have money, and I saw that you are also there, Vian. I don't know if you can push it there.
Okay.
People there may have the money, and they may relate with the cause of learning, and they may be programmers. Like the audience there is not a little noisy like Twitter. Twitter can work, but if you put it there, you are at more chances of getting someone to buy. which is good actually.
So why
So
did
that's
you
what.
say that I'm on Fakasta? Okay, that's really good advice. Yeah, I'll really hear from Manuel and see the way he's on it. By the way, Fakasta is a good place. I think it has. We can even target Jesse Pollack, the founder of Base, and see. I think yeah. So I will see. I don't know. Yeah, let me. Since today was the first time I heard about Manuel really talking about it fully, I will continue hearing about his plans and willing to support like on this collection. And it's exciting. It's exciting to see that people are practicing what we are learning and we are finding value in it. Yes, I guess such conversations are somewhat good. So I think we can start. So I can start with a small recap from yesterday. And yesterday we were talking about automated market makers. Today is going to be a continuation of that. And I think, yeah, maybe the next 3 days, on Saturday, we surely shall not have a session. I think, yes, because of the roadshow. Also, I think if all has been just as normal as possible, we shall have sessions in these days. But maybe if we have like some bit of up and down, or then we shall have like some communication. But yes, we really talked about automated market makers, and when you want to look at it, we said what makes a market automated. Simply the capacity and capability of users providing liquidity and being, and also sort of, because a market maker is simply for example, when you have something like a ledger or an order book, not a ledger, an order book. So no, where did you call this? All right, yeah, sorry about that. But an order book, if you have like one, yes, those who provide liquidity, and maybe those who ask for example, if I have 50 of token A and I'm saying I want 100 of token B from this. If I get another person who wants 50 of token A and has 100 of token B, then that is matched. For example, that order is matched, and through such interactions, then markets are made like during, it's like sort of auctioning to and fro from the different parties in automated market. And then the providers of liquidity are mostly the investors of the exchange if it is centralized, or the builders. Whereas with automated market makers, it is the users that provide liquidity, and yes, they are called liquidity providers. And oh, sorry. Yes, they are called liquidity providers, and then also it's users that purchase. So that carrot trade. So you find out that with automated market makers, they work like all the things are done on chain. When the makers of the market create the DEX, we looked, for example, at the decentralized exchanges like Uniswap. They put all things into consideration, how they will be earning probably from liquidity provided, yeah, and then everything behind Uniswap is a smart contract, and how like the liquidity providers will be earning and things like that. So most of this you can find in the Uniswap documentation. Yeah, so we looked at the different Uniswap versions, and just a recap of what each brought. And we mainly looked at in the initial Uniswap V1, if you wanted to swap from token A to token B, which was launched in 2018, you had to first swap from token A to ETH, then from ETH to token B, and then in March of 2020, the version 2 of the Uniswap was out, and these enabled some other additional features like swapping between ERC20 directly and then chained transactions, of course. Yeah, so almost every Uniswap version has been adding more complexity and add to it, yeah, things like that. So we deeply looked on Uniswap V1. And we looked at these four things. Anyone can add liquidity to become a liquidity provider. Liquidity providers can remove their liquidity and get back their crypto when they want. Users can swap between assets present in the trading pools, assuming there is enough liquidity. Users can, be charged a small trading fees that gets distributed among the liquidity providers so that they can earn from providing liquidity. So that's like incentivized mechanisms. And we really looked at a very fundamental equation that these markets are hinged on, which is x times y equals to a constant k. And we said x or y, these can be two different tokens. So yes, this is really a very fundamental equation. And we also looked at a scenario where so x is the balance of ETH in the trading pool, and y the balance of token in the trading pool, and k is a constant value. So we also looked at a scenario where, for example, if you want to swap a given token to another, so that means that the token you're swapping from, that amount that you're swapping will be reduced from that token, and then the token you're adding to, there will be some small amount, or there will be some amount that will be added onto that token because you are swapping to that token. And then from this, we expanded to have such an equation from what I've explained. And then we had something to solve based on that equation, And we looked at something very fundamental, that when this equation was created as a fundamental to ensure that the initial liquidity provider really most of the time suggests like the relativity of exchanging, and then other liquidity providers like use the exchange that has been provided by the initial liquidity providers of the two token pairs to play around with the liquidity. Yeah, so we also realized that with such an equation, actually the pool really or does not get depleted. Not really, but does not get depleted, because this equation leads to an hyperbolic curve, and as you're tending to zero, it never gets to the zero mark. So I really don't know if I still have so this was the curve that we looked at. That when you fill digits within these two equations, and you plot a curve, you will realize that you don't get to the zero mark. So when the pools are created initially, even when you want to remove all the liquidity you provided, there will be still some small percentage of liquidity that will remain in the pool. And that's a very fundamental with these markets, and like Uniswap. So we had, of course, some calculations going just through it, and then we really talked about the liquidity provider tokens, which are LP tokens, and we talked about that whenever you provide liquidity, an exchange of LP tokens can be minted for you as a proof that you provide liquidity, but also to give you the shares that you own in the pool. which is a basis for you to get rewards from the gas fee and rewards that are given to the liquidity providers. So we looked at fees and we're asking questions: do we collect fees in ETH token? Do we pay rewards in ETH tokens? How do we collect fees on each swap, or we use the other token? So yeah, that's, I think, a summary of it, and you can expound more on yeah, this Uniswap thing. So today we are going to look at code. We are going to see how we can create a Uniswap v1. So we have our rise pad. Let me see if I can get it here. I think I'm thinking that for the some of the coming days, I think this week we should revisit NFTs and write some code around their use cases. But it also seems that the decentralized exchange topics are really fun. People can really see the bug. So yeah, the pad is so yes, this rise up, I don't know what they call it. I will call it a pad. Is really to help us http pad.rise. So I've given a wrong one. Pad.rise up dot. Oh, it is pad. Yeah, thank you, Manuel. So I don't know if I have to, how do I delete this? I think, Manuel, you can pin that so that this does not distract. My link does not. Okay, just ignore. Alright, so yeah, if you join, go into the rise part. We want to sort of like keep engaging there. If there is something you want to share, maybe some code, you can paste it there so that other people can type along. And today is how do you write 4th March? So is it 4-3 or 3-4? So yeah, 20. Yesterday the rise up seemed to be amazing. I saw during the people were doing calculations from some rise some rise up part, and I was like, the speed is on another level. But I can have name, name. Then what did we put here? So today let's make it a bit fun. We can have name and then X handle. Yeah, and if you have LinkedIn, you can also put it. So join, copy that link. Maybe but today we can use name X handle. And I think because of this rise up, we are really going to be coding together. I'll try to paste code and then I code as you people are coding or something like this. So my X handle is at Kokosovian. So yeah, let's take it on, like you can register. So I'll leave that space for that. Just come, put your name. Yeah. And we can also have wallet address. So this will help us for those who will need some test tokens. Yeah. So this is optional, but the name and the Twitter handle is a must. Yeah, so I want to see people typing something. Great seeing Aima. So this bootcamp is to teach us great things. Okay. Yeah. So click on the link in the part and let us see who are joining in. Have I lost the? Okay, let me try to. All right, I lost this. Okay, so today we are going to look at building. I think I shared the wrong address. This address is not the address I need to share. Is this one? So as we said, the address you used for building is not the same address used to always store your real funds. So this address is the one I use to store my real funds. And this is the address I used to build. Okay, it seems people are looking for their X handle. Should be in your head. Awesome. I think I should give us some time and then we get started. The reason is really, I want us to be on the same page whenever we are starting some bit of code. Yes, follow each other. Follow at AgriCanuro. Let me give us some time to follow. Let us follow each other. Yeah, let's grow together. See what someone is doing on site. Look through their posts. Like, give a thumbs up. Ronnie Mwanje is there at their address. Nabuma Teddy. I'm not seeing your ex handle. Emmanuel Bagole is there at Prime Manuel. Yeah, let's take off some time and we follow. X is a big part of this industry. Okay, at Twin Kekari. So these are the only people. I'm seeing more people in the groups, but yeah, for now let's. I think we can start. So today we are going to use Foundry. Back to Foundry. Back to Foundry. Back to the days of Foundry. Let me really hide this and. I was starting to try out this, but so documents, middle. Let me create a new folder. Uniswap -v1. So today we are building the math that we talked about yesterday. So I think we need more of building projects, like mini projects, and I guess the next days we should keep building just so that we get used to it. So we know that if we need to start a Foundry project, we start with Forge in it. Foundry -up. Do I need to always share these commands in the Rise Up? Okay, let me also learn the Rise Up. So you realize that Foundry is really moving fast. Yeah. So the command is, sometimes you have to always cross-check these commands. So if I put it in these quotes or in these quotes, I don't know if I should. forge init foundry -up. So after that, we are going to seed into that directory. And then we install the OpenZap line. So we use forge. This rise up it gets deleted in 60 days, so you can always come back to it. OpenZap line. So you can copy some of these commands. But please type them. cd foundry up. So we have looked at the foundry, sort of the forwarder structure. And most of our smart contracts, not most, our smart contracts are always in the SRC forwarder. So this is where the smart contracts are always. Then scripts, lib. So you find out that, for example, for things like Uniswap or other exchanges, when the smart contracts are deployed, like even other firms or like builders can build on top of them, like build front ends on top. And that's also one of the things that is receiving a lot of rewards in the Web3 space. So if you can build front ends on many of these things, yeah. So forge install, error, git some modules exited. So maybe there is some error with okay, let me recopy this. So it is good to test as I So I think I had written it wrongly. The spelling that is in the pad is the right one. I've changed it a bit because I'm seeing they are now receiving the objects in my app. So we started with forge init foundry app. This can be any other name. Foundry app can be your app name. Then we change directory to that app and then forge install OpenZap lane. I think for sure we are going to be doing a lot of hands-on these coming days to keep getting more familiar with these concepts. Foundry, I get a lot of feedback that Foundry is intimidating. Sometimes I also do, but find it intimidating, but then it's also very swift and precise in doing many things with smart contracts. Is it my internet that is slow? I think my internet is slow. Or there are many people on site. People are eating up my internet. I'm going to become. Because Open Zeppelin is a very fundamental part, but I think Open Zeppelin files are a bit bulky, so I should better start asking people on site to give me a cable also. So really my thing is exiting. Let me first check the internet and be back. Okay, I think we can continue, and let me try one more time. If it doesn't work, then I will start a new repository and follow through the steps. So 10%. Okay. Right, so this has failed, but there is some, I think, test v1 had downloaded like well, so I'm going to use that, and I stopped at that. So cd foundry app. So when you look here, I think I already had that Open Zeppelin. Yeah, I have the Open Zeppelin here. So it was downloaded. So the next command we are going to do is create remapping, so that we can configure Open Zeppelin to the remappings txt. So yes, the command is in the rise up. So yes, as soon as you do forge remappings and then remappings.txt, you get the remappings.txt file here, and when you click on it, inside already there is the Open Zeppelin contracts, okay, like contract directories. Hope we are together. So I think we can start off by creating the environmental variables. So inside our Foundry app, we are going to have the .env file. And we can have things like the private key. These are the ones we shall need while deploying the smart contracts. Private key, RPC URL. Then also Etherscan API key. Etherscan API key helps us to verify. So for the private key, I think we know how to get it. You got your wallet address, and never share your private key, because if it is leaked, account details, show private key, and then you put in your password. So that's how you get the private key. RPC URL, you can use Alchemy or Infura. So let me use Infura. Infura.io. Please, if you need me, for example, to write something in the Rise Up, you can tell me about it, and I do. So said private key. So private key, we've said from MetaMask, and is secret. So RPC URL, RPC, you can either get it from Infura.io or Alchemy or any other RPC provider like QuickNode. Yes. Then Etherscan API key from Etherscan. So right here on my Infura, if I log in, email, I don't know whether this is an internet issue, but yeah, at last. So I'm here in Infura, and of course I have these two apps. I think maximally you can have access to two apps. So if I click on one of them, here there is all endpoints and active endpoints. Hope you people can see my screen. If you have any question, you let me know, because I'm not seeing. Okay. So I think for this we are going to use Sepolia testnet. The homework probably could be deploying on Lisk Uniswap v1. It's amazing. So this is the Infura RPC endpoint. For those that need some testnet tokens, we had some facets that didn't need for you to have anything. So I don't know if somebody has any link to such facets. You can share in the group, so that people equip themselves with some tokens, some testnet tokens. I guess I had one here. Manuel, do you have any links to any? Or have you shared any? Because I'm looking for some here, I've forgotten its name. come across one, please share one in the.
Yeah, I've shared one in the chat.
Okay, that's good.
But its only issue is that it offers only 0.05 Sepolia ETH for every 24 hours, for every Google account, for every address.
Tujatandikira awo. All right, so we can continue. The third thing we're looking at is private key Etherscan API key. So if you go to Etherscan, even when you're going to upload on Sepolia, so Etherscan. .io. There is a sign in button on this side. So when you are on Sepolia here, there is no sign in button if you're on the testnet, but if you're on the mainnet, the sign button is there. Username. So if you don't have an account, you can sign up. Oh God, no, not this time. Okay. So here, of course, you can get access to your API key around here, API dashboard. So let me take a moment and populate my .env. This should be in. So I've finished to populate my .env file. I hope we are really moving together. If you have any questions, please you can ask. Any questions? Yeah, if you need any links. So Etherscan link, you can get it in Fura. As we are going in this second month, really, we need to be a bit like, since we now know the overview of the picture, we need to get this concept. So moving slower is okay, in a sense that slower means in a sense that everyone is trying out. So infura.io, then Etherscan. I think you can just Google it. Yeah. So after that, I think we can go to making an ERC20 token. So let's start off by creating really a simple ERC20 token that will be used to create the trading pool on our exchange. So we'll just use a dummy token. And so let me try to see if I can share this code. I'm going to be copying up, creating our dummy token. I think of yeah, I've put something in the rise up. So you can type it and or you can copy it. So and you come to your project under SRC. So you can probably have a file called token.sol. So we can go through it. The license is MIT. So most of what I do with this Pragma Solidity to get the Solidity version, I look in the token that I found out when I initialized. So when I initialized the Foundry project, the Solidity is greater than 0.8.13, and I prefer taking this one because this one is already a sole compiler that has come with the project. Solidity compiler, Solc. So yeah, we have import open Zeppelin contracts. Of course, to import the open Zeppelin. So the start and end should not be there, so this end should not be there. At the same pace. So contract, and let me save. So that means that we have the contract. You can initialize the contract name as token or TKN. It can be the central code or DCT. It could be your name, like, yeah. And then we want to mint to the deploying address, sort of a billion, yeah. So this 10 star decimals, decimals were 18. Yeah. So we shall have these initial mints. Okay, is that okay? I need some thumbs up. What will be code? Okay, good. Thank you. So it's, of course, it's a very basic IRC20. That means 1,000,000 tokens to the deploy address. So now the next thing is we are going to start making the exchange contract. And the fun part is coming. We are hinging on the concepts that we did yesterday, but even if you are not part of yesterday, we are looking mainly, the whole concept is hinged on the two mathematical equations. And of course we have to have the tokens to exchange, but we also need to have a smart contract that allows for that, or that is programmed to do that. So here we are going to create a new file. We are going to call it exchange.sol. And I think we can start it. Let me see if I can put this code in the Rise app. So I need your feedback about this mode of teaching. I'm adopting it to see that we can follow as much as possible, and also can have access to these contracts after the sessions. So I'll put the exchange.sol smart contract in the Rise app. So we are going to be building on that smart contract and adding functionalities to it. And now we can go, what is this? No arguments first to the base constructor. Okay, so let's add in more code. Now we can go step by step by adding the functionality. First, let's create a constructor for the contract. So the constructor takes the contract address of the token and saves it. The exchange will then further behave as an exchange for ETH and that token. So here where the future code is going, I think so. Yeah, I've added some more code. Probably if you don't get it like right now, you can come back to it and keep, because that's the best way I can explain what I'm adding. Maybe by the end we shall have the full contract tested and see if it works. So we started having the constructor. we talked about liquidity provider token, and what we are following actually mostly is as per this explanation. So we must have liquidity provider tokens that we are going to give to those that provide liquidity as an assurance of the shares that they have in the liquidity that has been provided. So now we can start looking at functions. Why is this giving me an error? Okay. So let me add this in the rise up. So now we can create a simple view function that returns the balance of token for the exchange contract itself. So how many token or tokens are in the exchange contract. So we have to get the reserve balance in the exchange contract, and let me look at it here. So hopefully by the time our smart contract is completed, we have it. I'm starting to think that next time I will have the entire smart contract, paste it at once, and then we explain it. But yeah, let me first use this mechanism, because if I paste the smart contract once, like, people rarely get what is what. Or we shall go back to typing the way I used to type in session 2. So the smart contract is becoming a big. So returns the balance of the token held by the contract. And if you want to read the balance, we just use the public view returns. Okay. So now let's create a function to add liquidity to the exchange. So I think the best way to do this is to have this being explained in the comments. Yeah. So if you are maybe confused about how we are calculating certain things, you can refer to our lesson yesterday. I highly encourage us to go through it, which introduced on how exchanges work, and we went over the math equation. So actually, that's why yesterday we had that issue of talking about those functions. This function is really huge. So I've pasted it in the rise up. Probably let me make it clear. So it has add liquidity. Are we moving together at least so far? Any response?
Yes, we're moving together. So
God, thank you for that. So the function to add liquidity. So I think I've not added the entire function. Most of the things, there's a lot of commenting, but we can go through. So this is function add liquidity, of course amount of token. Maybe you are adding liquidity between an ERC20 token that we deployed, which is token.so, which we are going to deploy, and then also ETH, or one of them. So one of the things that we saw, that when you add liquidity, then you must be deployed, like LP tokens should be minted to you as a show of your shares. So we can look at the ETH reserve balance and then the token of the reserve balance, and yeah, we'll look at the balance of the tokens of those type in the reserve, and also the biggest thing is mint for the sender, LP tokens that represent the shares of the liquidity they have added in the pool. Yes, most is into the comments, I think. So we have looked at different function, add liquidity. We have looked at the reserve. So we can also look at the function to remove the liquidity. So since now adding liquidity is now possible, we can look at removing liquidity from the smart contract. Code has been put in the rise up. check. So this is the code to remove the liquidity. It will allow the users to remove their liquidity, and of course when they remove their liquidity, their LP tokens must be banned or converted back or removed from them. Yeah, there should be that mechanism. But also we saw that there is a mechanism to ensure that the liquidity pool does not deplete to zero. There will be some small remaining percentage even when somebody removes all their liquidity, like, yes. And there are reasons to not deplete to zero. One is the gas fee. Second is due to the fundamental equation of the AMM or the DEX. Yeah, we are still on. Great having everyone on. So we looked at this thing gives me a hard time, but so as we are looking closely on this, we looked at this equation, which is x plus the swapping, that wherever you are swapping, there is an increment of the token you're swapping to and a decrease of the token you're swapping out of or from. And now we can create a pure function that can perform the calculation of let me write it here. So since equation 1 equals to equation 2, is the same as 2, so we can have a calculation that does x, that returns x star y being equivalent to x plus dy times y minus x plus dx, this function times y minus dy. So we want to write a function that does this to estimate how much ETH or the token a user would get back given they want to sell a certain amount of the token or ETH to the exchange. Yeah, so we want to use this to ascertain and I can add this code here. So the code has been added to the rise up. So get output amount of swap calculates the amount of output tokens to be received based on this x star y equals to this equation. So this is the function. Yeah, let me first add it. So should we still add on the smart contract? um, so yeah, with this in place, we can, I think, create the two core swapping functions. So ETH to token swap and token to ETH swap. So it is very funny, but it's like math being translated into code. And as actually Emmanuel was explaining in the morning, he said you could look at this thing and you think it is pure algorithm, yet it is pure math. And yes, as you start specializing, for example, on ZK, you can write like ZK code, and it is just an implementation of the proof, like the function. Same to stacks, the way stacks were derived from the polynomial. Yeah, let's continue. So when we go to the rise up, I bet we better stop here on adding something to, but yeah, so we have the ETH to token swap that allows users to swap ETH for tokens. So when you look at here, you have tokens to receive because get output amount from swap. So message.value stands on the value to get address this balance. Of course, you subtract amount from msg.value. So it's like if you're going to swap, you have to subtract it from the amount you have in the wallet. And then we also have another token reserve balance. Yeah, so you have to pass through these two things. So we have looked at the require, but this simply means that so tokens to receive must be greater or equal to minimum tokens to receive must be fewer than, all tokens to receive must be greater than the minimum token to receive. It is simply a statement that this, like, you should receive an amount that is less than what is available. Otherwise, minimum tokens, I think I'm wrong on this. I've taken so require means so require that, oh sorry, my mic was off. So require simply means that the tokens to receive should be equal to the minimum amount of tokens to be received from this, because we are getting out these tokens from the swap. Otherwise, you can return some error. Yeah. Let me first run this code and also see if it works. So I think it starts from here. So we want to deploy these contracts. So with the code now done for both of the contracts, let's deploy our contracts. So we will have to load the environment variables into the terminal's environment variables. And for doing this, we are going to use src.env, source.env. This source code is going to be in the Rise app, and I think there is a lot of like statements to explain what we are doing, but it's also a good thing for those of us either attending online to touch the code and go through it line by line. So let's first try to see whether it runs. So since I've function with same name and parameter types defined twice, so did I define something 2 times? Okay, so I'm going to delete the counter.sol. And I think to make it easy, let me try to just copy the entire thing. I think the error is gone. Okay, so we save and we save the token.sol. We have minted 1 million, so command to load the environment variables. Source env. So the command has been pasted in the Rise app. I think that has been successful. And then we want to yeah, we are still moving. First, if for the next sort of commands to deploy a smart contract, you have to ensure that your terminal is pointing on Foundry app. So if your terminal is outside, maybe it is a test Uniswap v1, should be pointing at Foundry app, and the command is forge. So we are going to run it and see if it works. Forge create, it's a long command. And funny, I was reading about this command, and then I ran the command that was given to me, and it didn't work. So yeah, now I don't want to. So was it RPC URL? So let me first stop sharing my. So I'm going to first test the command, and then if it works, I will really write it for you. So I want to get my env. I'm just going to get the variables like private key, and I think put it here in token.so. So Ctrl V and so I guess my presentation skills are improving daily. So yeah, we are going to have these. We know we used our environment variables to store these crucial information. So you have forge create dash RPC URL. So this is the command that will RPC dash URL. Then we put the environment variable thing for RPC URL, which is RPC underscore URL, the one we got from Infura. So we have also dash private key, private dash key. So this is the command for deploying, and then so dash etherscan dash API key. So let me do Control M. Oh, it's supposed to be Control B. So Control or Command B. Yes, I want to just API key. And then we have etherscan underscore API underscore key. So when we have the API key, we can also verify the smart contract dash verify. src slash token dot sol colon. So when you look at token.so, we have token.so as the smart contract, and then the contract name is token. So here I shall say call the contract name, which is token. So let's enter. Compiling, finished. Compiler run successful. Oh. So you have to run the broadcast. So this shows that, the contract has been compiled successfully. But we have to add the broadcast. So to broadcast, add broadcast to provide commands, forge create help. Let's see, broadcast. So this is what I was saying, that sometimes these commands you have to have them somewhere, or you have to do a lot of try and error, because the forge docs really changes very quickly. So I believe I wrote it somewhere. Forge create RPC Etherscan verify dash broadcast. Okay. So let me clear. So back, this is dash broadcast. So initially it was just that command, but it was I think improved, or yeah. So you need to always be reading let's first finish it, and then I share the Foundry docs. And why even would you need Foundry? It's because really Foundry does a lot of unit tests, and one of the big issues in the industry is hacks. So you have to run a lot of tests. Yet if we are using Remix, things could be sharp, but you suffer hacks. So yes, this is interesting. The thing is deploying. And verification is still pending. I guess I should also, so contract successfully deployed. Let me put this command in the rise up. Where is I had Mr. Manuel had shared some. Manuel, does this thing need you to have anything? Like I can get tokens from it.
Sorry, I didn't hear what you said.
So this link you shared, like anyone with 0 tokens on their wallet can get some tokens from it.
Yes, yeah. Anyone can get, as long as you share an Ethereum Sepolia address, you're ready to go. It only gives 0.05 in 24 hours for every address. That's the only caveat, but otherwise it works.
Okay, let me try to get some tokens. yes, I have to keep my wallet having some tokens, because sometimes if you face a deployment issue, yet you don't know that it could be your tokens, you have to be sure that you have to figure it out. So I was talking about sharing this in the rise part. Are we moving along? I think I should stop asking the question. People are already irritated by the smart contracts. But it's fun. So we have deployed the token. So what I'm going to do is we are going to have a section for the names and the smart contracts and the smart contract addresses. You can do this work like away from maybe you can add your things, your addresses during the session or out of the session, but please make sure that you do something. So from here, you have to copy your deployment address, because you will need it as a constructor in the swapping contract. So here, when we deployed, we had a deployer. This is my wallet, and then deployed to. So this is the address, transaction hash, starting contract verification. Yeah, so everything was verified, deployed on Sepolia. So yes, so deployed to this. So you need to copy this address, because we shall need it. So you will paste yours somewhere there down in the rise part. Yes, we just want to see those who deployed. We want to see those who didn't deploy. Maybe you got issues. If you have other builders around you, you can take it through both of you, and yeah. But that should be, I think, after here. So let's go on. So we want to run the command to. I think let me just leave this terminal. I might need something from it. So let me add the new terminal. So you see, when I add this new terminal, I'm in Uniswap v1. So I should always be in the Foundry app. cd Foundry app. And also you will find that maybe you're reading some article and doesn't have the broadcast thing. So you should always refer back to the docs and newer docs. Yeah, will give you the commands. But for now, that command worked, and it is in the rise up. So we want to deploy our second smart contract. Forge create dash rpc and dash url. So we say this is our rpc URL. And then dash dash private key. Since it is a variable, so in previous class, as I was practicing, I used to put the constructor arguments after here, but let's try to put it, because most of the commands in articles do it this way, so yeah, maybe it works. Dash args. So this constructor arguments, because we want to deploy the token that we shall be exchanging in the pool. We are going to give it as the address of the, so it is this address, and deploy it to this address of our smart contract. And then of course etherscan dash API dash key. We can have this variable, which is in our environmental variable. And then verify src exchange sol colon exchange. So a value is required for rpc URL. I realized that this error, so this is what most solutions like give, like this is how you write the command, but I realized that okay, when I really changed the constructor arguments to be the last, it worked in my previous one, so let me put it as the last argument. Yes, has someone put up a hand or?
Yeah, yeah, Vian, there's a slight error in the word constructor. I hope you've seen it. The spelling was wrong.
Okay, thank you. Let me first rectify now that one, and all right. it's not coming back. So there is an issue in the constructor args. Forge, create RPC, natural private key. Yes, I had to put this S. I think that's all. A value is still a value is required for so one of the solutions I read and tried out and it worked. Hopefully it works here. I read it from the Forge. Let me not forget to share it. From the Foundry book, where is it? It is here, Foundry. Is that constructor arguments should be placed as the last arguments. I think they try to confuse Foundry. So let me share the book here. Hope you guys read it. So immediate after the API key, then we can have constructor args. Before verify. So constructor args. And then I'll copy the address. So verify is dash verify. I guess I should take some water. So I don't know why Forge create RPC dash URL. So I don't know why this is still coming. A value is required for dash RPC. Forge create RPC URL. Let me see here how it has been. So Forge create a dash RPC URL. Probably I can copy this. I know that mostly this issue comes from the constructor arguments. I don't know for what reason. Forge create RPC URL. Private key is the same private key. API key. Scan API key. And then constructor args. This is not token.so. Exchange.so, and contract is exchange. Yes.
Okay, Vian, I see the file token.so seems to have some pending work to save. Could it be that you've changed something and it's reading the old file?
Token.so.
Looks, yeah, it looks like you have some things that haven't been saved yet. I don't know. Maybe you could have changed something, but you haven't saved it to the file that is being run by Forge.
So for token.so, I think I successfully deployed it, or I should redeploy it. Let me control save and then redeploy. Because when I deployed it, this was the result. So the issue I'm facing is with Exchange. That's why I want to have this very open so that because it is telling me value is required, but okay, let me try to run without construct arguments. What could be the issue? Why? A value is required for RPC URL, which is URL. Forge create RPC URL. Does it mean that I don't have my RPC URL in the .env? All what I can do, let me run this in the same terminal. So let me close this terminal. Let me leave it. So here it is giving me yeah, was the error at least I expected. So the following required arguments were not provided. Contract. So usage, forge, create, RPC URL, private key, etherscan, constructor args. Okay. RPC URL, private key, etherscan API key, constructor args, verify. Okay. So does it want us to remove the verify? Verify src exchange.sol exchange. So for this error, if for some reason I remove our constructor arguments, and press enter, it works. And it tells me no arguments provided. So for constructor, consider. I think there was some smart contract I really passed that error. If not, we are going to use Remix to deploy it. So forge, create, remapping, self. Dash contracts. Yeah, so here there is a note. The construct args must be positioned last in the command since it takes multiple values. I think should I paste it? So the path to a file, verify contract after creation. runs forge verify parameters. So I think what I could do is to remove verify. So for my information, try help. Um, okay, so I think we can use remix. We shall look for the error with it. I really find some issues with constructor arguments. I don't know whether it is some issue, but yeah, there is an issue with the construct arguments, even from docs. I think there is a moment I really had gotten a way to go over it, but I think I will revisit my notes or look through on how to. So exchange.sol, and then we copy the entire piece, we paste the entire piece of code. So you could use Remix, but the reason we really stick with Foundry is because it gives us that capacity to run tests, and as you build more, you realize that the value of smart contract engineering is in running tests and ensuring that the code is doing what it says it does. So this domain, Remix may not give us those capacities as deeply as Foundry. So here we're going to choose injected MetaMask, injected provider. And the chain is Sepolia. So here on deploy, there is address token. So here we put the contrabactics. So here we really get the deploy smart contract as our constructor argument, which we shall put here. So exchange.sol, and then we click transact or deploy. So gas estimation error with the following message: send transaction. Wow, 200 of gas. Hopefully I have so also on one hand I don't know why. So let me send to my address. Zero point 0.05. Sometimes a foundry is better at deployments also because of its estimation of gas. I don't know why sometimes when you connect to injected MetaMask, gas prices become a bit exorbitant. So 0.09, I think that's okay. Yeah, we've added in the smart contract, so I can deploy. Okay, I think now I can deploy. Confirm. I don't know how much gas I've used, but so my deployment has been successful, and we can look at my deployed smart contract from here. So let me pin it. Exchange deployed at this. And the rise up. So yeah, I think we can now verify our smart contract. If I go here, there is this contract verification. So select chain. I think Sepolia is here. Contract address, Control V, and exchange. Yeah, let me try to verify. Satisfy. I think it has verified. So I can copy the address and go to Sepolia scan. So Sepolia testnet. So Sepolia is getting depreciated and Holoske is coming. So it is not yet verified. Sourcefy.dev. Okay, it seems also Sourcefy has verified. No. So maybe I should click here, verify and publish. Please select compiler. So it is single file. Compiler version. .26 commit. 8.26 commit. The open source license, MIT. Agree and continue. And verify. So if you are going to verify, what you do, you flatten your smart contract. So exchange.so, because it has it is importing OpenZeppelin, so I will flatten it. Right click and flatten, and get exchange flatten.so. So you copy and paste, and then verify and publish. So yes, the contract has been successfully verified. Yeah, I think having deployed those smart contracts, we can call it a night. And any feedback? Yes, so we can go back and really do some revision on Uniswap V1. Yes, Mr. Ronnie?
What exactly does the flattening do?
So flatten removes all the imports. So for example, this OpenZeppelin, when you look at exchange.so, so this OpenZeppelin is some smart contract. So instead of importing it, it makes it a single file. So when you look into our exchange, all the interfaces and all the files are imported. So there is no import. The interfaces are here, and that's what it usually does, so that we have a singular implementation. Yes, and that's why when you look at the flattened code, it is too much. Like everything is brought into one file. I think that's what it does well. Because if you are verifying, the website will look for that Zeppelin file, and then it has to verify it to and maybe it will not find the path. So yeah, that's what it does. What is your feedback on the model of teaching? Should we keep having such maybe copy pasting code? And how are you guys finding decentralized exchanges and MMs? I think we have people like Mwanje here who provide liquidity. Uh-huh.
I'm excited. I think the mode of teaching is wonderful. I'm only wondering why the deployment failed on Foundry, and uh, because of all the functionalities that it has better than Remix. I don't know. Guys, are we going to kind of find out later? Will you let us know if you resolve the issue?
So I've had like some issues with constructor arguments, because when we looked really on Foundry, the time when we deployed, there is a deployment that we had, and it asked for us, when, for example, when we remove the, I think it is here. So when we remove the constructor arguments, you see the compilation is successful. So something that also you builders can research about. I've been researching about it. There is a time I think I passed by it, but I don't know where I placed that code. So if you get a solution, yeah, it would be really awesome. Otherwise, I'm also doing research on it the same way. So I don't want builders to wait on me that it works. But yeah, in any case, if I get it right, I will really bring it here, because we are going to start having like these big sort of codes. I want us to get used to reading code like that. So yeah, but in case someone who is here gets it first, yeah, you can share. You feel free to share. Any other additions? So here, if I'm to search this one, it has the tick here. So now both of our contracts are marked, and we can interact with these contracts. So this is the exchange smart contract. When we go to read, it has these functions. People should start creating front ends, so that whatever contract we deploy, like you just plug into your front end, just get the ABI and then the contract address, and play around with it. That's the allowance, balance of decimals, get output amount, like the exchange itself. So if you build a single page on top of this, and then you can also write to the smart contract even without having a front end yet. So you can add liquidity, approve ETH tokens to swap, remove liquidity, token to ETH swap, transfer from. This is incredible. Like, I think since I minted, so if I'm to write to this smart contract, I have to connect my wallet. And then I can add liquidity, payable amount of liquidity. So let's play around with it anyway. More feedback. I know we seem to be a bit early, 1 hour late, but the content is much enough for people to ponder upon. Those who were not present in the previous lecture maybe can go through the 3-hour deployed video. And I also encourage us, follow Decentracode. I think these guys of these builders of CodeGen are really doing a lot of work. I see them here like having sleepless nights. So giving them a thumbs up, a feedback, and I like on their content would be awesome to them, like to boost their growth and keep doing what they are doing. You know, it's really tight, and releasing content weekly is really tiresome. So yes, I think one time we should have some session with Ronnie. Maybe if he comes, on site, a sort of an interview. Manuel, you better invite the man himself, the lion himself. Any feedback?
Yeah, I think with today's session, I'm even more confident we're taking 52,000 this week.
Okay. All right. Yeah, I think we can have a stop at that. Otherwise, unless someone else has something to say, have a great night.